particle of mass 9 kilograms is held at rest by two light inextensible strings, both of which are fixed to a horizontal ceiling. The angle of one string is 20 degrees to the horizontal and the other is 50 degrees to the horizontal. Find the tension in each string. So this is actually a question we've done before, and we actually did it before by vertically resolving horizontally and solving the simultaneous equations, and we got that T1 was 88.2 and T2 was 60.3. We're now going to look at doing it another way and using the fact that forces are vectors. So we can take our, let's just take our 3 vectors, and we can put them tip to tail, and because the particle is in equilibrium, it must form a closed loop. So I have, for example, my 9G, let's draw this up here. I have 9G, weight straight down, and then I'm going to put my tension 2 in there, and then my T1 going from tail to tip in that direction, and it must form a closed loop because the particle is in equilibrium. Okay, so I'm going to use that, and I'm just going to use a vector triangle. So I know that T2, let's label this as T2, this one's T1 and this one's 9G. Let's label T2 as 20 degrees above the horizontal, so that's going to be 20 in there, so we know this is going to be 70. And we also know that that's 20 there. This bottom bit is 20, but we know that T1 is 50 degrees above the horizontal, so that's 20 and 50, so that's going to be 70. And then we also know that this angle must be 40. We know that because angles in a triangle are 180, but we also know that the 40 is this angle here. So now we've got that, we can just use the cosine rule or the sine rule to figure out what T1 and T2 are. So the easiest thing for us to do is to do T1 divided by sine 70 is equal to 9G over sine 70. So that's over sine 70, if I times by sine 70 on both sides, you can clearly see that the sine 70s are going to cancel, so T1 is just equal to 9G, which is 88.2 newtons. And we could have done that really quickly here because we can see that it's an isosceles triangle because we've got 2 angles equal, so these 2 must be equal. That would be a really simple way to do it in the exam and save you loads of time. T2, if we're using the triangle, we can say T2 over sine 40 is equal to 9G over sine 70. 9G over sine 70. So timesing through by the sine 40, we get this situation. And if we do 9G divided by sine 70 times by sine 40, and we get 60.3, which is the same answer as we got previously, but I think you'll agree we did it in a much quicker way this time.